Alrighty. Okay, so from the very beginning of this unit, we talked about what's called parent functions. Remember, parent functions are the functions that it's the original. Nothing has been added on. It's very just simple, straight to the point. Okay, so our first parent function that we need to graph, the whole front page is just graphing the parent functions. These literally took us like less than a minute to do. Okay, so what we did, you guys will remember, we gave ourselves a little table. One column was our x, one column was our y. We chose numbers to plug into this function, -1, 0, and 1. And then once we plug them in, we're going to see what we get out for y. What I mean by that? Okay, if I have x squared and I'm plugging in -1, what is -1 times -1 or -1 squared? It's +1. Beautiful. Okay, so if we plug in a -1, we get out a +1. The rest of them are pretty simple. We like 0. What is 0 squared going to give me?
0.
0. Plug in a 0, we get out a 0. +1's pretty simple too. If I plug in +1, what do I get out? +1. Okay, and those become what we call our parent points, our parent function points. Those are our coordinate points. Okay, so we can easily put these on a graph, and you're gonna wanna this front page is gonna help you so much on your test. Okay, so find these parent function points, -1, +1 for my first point, 0, 0, +1, +1. Okay, and this is a quadratic being taken to the second power. So remember, a quadratic is just that U shape. And there we go. Okay.
Wait, which one is this?
This is a quadratic. Ooh, yeah, let's put that on our paper actually. Maybe put a star by this. This is a quadratic. Great point. All right, number 2. Notice on number 1 it says f of x equals this function, and on number 2 it says y equals this function. They mean the same exact thing. F of x is the same thing as y. Okay, so first of all, it's taken to the third power. So let's go ahead and just name it right off the bat. This is called a cubic function. Taken to the third power is a cubic function. Okay, let's do the same thing we did for number 1. Give yourself a little table, an x column and a y column. We'll choose the same 3 numbers to plug in. -1, 0, and 1. Okay, this is the one we got to be careful with. What is -1 to the third power? Meaning, what is -1 times -1 times another -1? What do we get out? We get a -1. Okay, that's really the only one that's a little different. 0 to the third power is just 0. And +1 to the third power is still just +1. And there we go. There's our parent function points. Okay, so let's go ahead and put them on our graph. -1, -1, 0, 0, +1, +1. Okay, and remember, it looks like it'll create a straight line when you connect them, but a cubic function is actually kind of like S-shaped a little bit. But there we go. There's our cubic parent function. Boom. Okay. Next function, again, it says y equals. It can say y equals or f of x equals. This guy's to the 4th power. So he's what we call a quartic function. Quarter. Yeah, you get it? Okay, quartic function. Same thing though. Give yourself your x and your y. We'll do the same 3 numbers for this guy. Okay, if I plug in -1 to an even power, guess what? I'm always going to get a positive out. It could be x to the 96th power, and you'd still get a positive 1 because it's an even power. We know that you plug in 0, you get out 0. And we know if you plug in positive 1, you get out positive 1. Easy peasy. Okay, so now let's put these on our graph. -1, positive 1. 0, 0. Positive 1, positive 1. Okay, and this one kind of looks like it's going to look like our parabola for number 2, that straight little U, but remember this one kind of turns into a W, where it hits that, goes back down. There's our W shape for a quartic function. Love it. Eli's got our next name for our next function.
I don't know how to spell it.
That's okay, I'll spell it for you. And this is math class, who cares if we misspell some things, right? Okay, we see the little bars. That tells us absolute value. Love that. Love that that's on my video, too. Okay, so we know this is an absolute value function. Okay, so same thing. Give yourself your columns. -1, 0, 1. Okay, and remember, what absolute value actually means is distance from 0. So think of it like on a number line. -1 is 1 space away from 0. So if we were to plug in -1, we get out positive 1. 0 is 0 spaces away from 0. And again, positive 1 is also 1 space away from 0. So when we were taught, when we were little, the absolute value, you're always going to get a positive, right? But they never really taught you why. Okay, it's because the distance from 0. You can't have like negative distance. Okay, so those become our coordinate points. -1, positive 1. 0, 0. Positive 1, positive 1. Okay, and the difference here, remember it's not a U shape, it's like a perfect pointy V shape. And there we go. There's our absolute value parent function.
It's stretching its arms.
Okay, our last parent function we didn't talk about a whole lot, but you're going to need to know the shape for your review and your test. Okay, this one is our square root parent function. Square root. Okay, now he's a little different, and I'll show you why. Okay, so we're still going to give ourselves our table with our x and our y column, but I'm not going to choose the same 3 numbers that I've chosen, okay? Because it is impossible. Let me prove it to you. If you were to pull out a calculator, because we've been plugging in -1, right? We've chosen a negative number. Well, let's see what I get if I try to type in the square root of -1. Not possible. Okay? So we can't choose any negative numbers. And I'm going to make it easier on myself. I'm going to choose perfect square numbers. Positive perfect square numbers. Whoops. Whoa. Okay? 0 is a perfect square number. We can square root 0 because what times itself gives us 0? Don't overthink it. 0. Square root of 0 is 0. I'm going to choose my next perfect square number, 1. What is the square root of 1? Or what times itself gives us 1? 1. And I'm going to choose my next perfect square number. Now you could choose 2, but the square root of 2 is like a really long, ugly decimal. I don't want to graph a really long, ugly decimal. I want to graph a nice, pretty number. So my next perfect square number is 4. What is the square root of 4? 2. Okay, so these parent function points are a little different than our other ones. Okay, so let's go ahead and graph them. We have 0, 0. We have 1, 1. And then we have 4, 2. Okay, so those are my 3 points, and this is how we connect them. because we can never go into the negatives, right? I just showed you on the calculator, that's not possible for a square root. You just start it at 0, 0. And it makes that shape right there.
Across.
Mm-hmm. Okay, awesome. Give me a 5 to 1. I can identify a parent function. Quadratic, cubic, absolute value. Nice. Okay, awesome. Turn your paper over then. So now we have, like we were talking about on our starter, numbers 6 through 8. It's just asking you to explain in words, right? You guys are all like juniors and seniors. You should be able to write a complete sentence, but this is math class. I'm not going to require that. Okay? Explain in words the transformations that are happening. So, we started off with a quadratic function. Quadratic function, that little square root, or not square root, square, power of 2, tells me that this is a quadratic function. Okay, so start by naming what type of function it is. This guy is a quadratic function. Okay, now let's identify the first thing that's been added on. It's this negative in front of my parentheses. Now, just like on our starter, when we had a negative, what happened? What did we write down on our starter? Flipped. Okay, and it's being flipped over the y-axis, meaning it was going up. Now it's been flipped. It's pointing down. Inside my parentheses is left and right. It's a plus 2. Is it going to the right 2 or to the left 2? Left 2. On the inside, plus means left. We have left 2. And my last transformation, outside, means up and down. My up 3 or down 3? Down 3. So inside, you kind of have to think backwards. Outside, it's pretty straight up. And boom, there you go. It is a quadratic function that's been flipped over the y-axis and shifted to the left 2 and down 3. Nice. Okay, let's go to our next one. Let's name this function first. So the highest power I see is 3. Look on the front page if you forgot the name. Third power, what's it called?
Cubic.
Cubic, nice. So this is a cubic function. Okay, now let's identify the transformations. Do you see any negatives out front? Nope, so it hasn't been flipped at all. Okay, so we can go straight to left and right. Minus 4. Is this going to the left 4 or to the right 4? Right 4. Nice. So it's being taken to the right 4, shifted right 4. Plus 5, up 5 or down 5? Up 5.
We're always singing his heart out there.
And boom, we're done. Okay, next one. Let's name the function. The highest degree I see is 4. What's it called when the highest degree is 4? What was the name? Isaac? Ooh, not quite. Absolute value was the 2 bars. Quadratic was 2. What about the 4th power? Not cubic, that was 3. Isaac? Quartic. I know, funny word. This is a quartic function. Any negatives out front? Has it been flipped at all? Nope, no negatives. Inside is left and right. Did it go to the left 5 or right 5?
Left 5.
Left 5. And on the outside is up and down, up 2 or down 2? Down 2. Beautiful, beautiful. Okay. It's all it wanted you to just explain in words what the transformations that have been added to these functions. Okay, now we're going backwards, just like on our starter. Now it's asking us, write an equation given the transformation explanation. So you're going to have to do this on your review and on your test. Well, easy part is you can always start every equation with y equals, or f of x, doesn't really matter. Alrighty, so first let's identify the type of function it is. So for number 9, it says a quadratic function. Wait, look back on the front of your paper if you need to. What power was the quadratic function?
2.
2, good job. Alright, so we know we're gonna have parentheses, x on the inside, and it's being taken to the second power. Okay, just leaving myself a little space just for those transformations to be put in there. Is it being flipped?
No. Yes.
Yes, it's being flipped over the y-axis. So what do I need to add that says it's being flipped in front?
Negative.
The negative. Okay, so we're going to put our negative in front of there. It's being flipped. Then it's being shifted to the left 2. Remember, inside my parentheses is left and right. But am I going to write +2 or -2 for left 2? Isaac? +2. So +2 on the inside because it's going to the left 2. And then finally, up 1. On the outside is up and down. Is this going to be +1 or -1? +1. And look at that. Your equation is done. Beautiful. Okay, number 10, we already started with the easy part. Y equals, you can always start with y equals. Ooh, how do I write an absolute value function? What does that look like?
Oh,
It's an absolute.
It is an absolute, what does it look like?
that's your ball.
Nice, the 2 bars, okay? So give yourself the 2 bars, x in front. Remember, it's not being taken to any power, it's just those 2 bars, absolute value. Is it being flipped? Do I need to put a negative out in front?
No.
Nope, no negative. Shifted to the right 3. On the inside is left and right. Is this going to be -3 or +3? -3 for the right 3. Great job. And down 4. -4. Boom. Dunzo. Okay, show me a fist of 5 on like numbers 7 or 6 through 10. Can explain in words and then I can go backwards. I can write an equation given words. How you feeling? Nice, nice. Okay. Alrighty, last 2 examples. We're gonna put it all together here. Now, we're gonna graph these functions. Now here's the beautiful part. If you have the parent function points, which you should on the front of your paper, okay, these are gonna help us a ton when graphing these out. Okay, what type of function is number 11? Quadratic. Okay, so maybe look to the front of your paper. Say, okay, now I know where my parent function points were. I'm gonna actually put those on the graph. -1, 1, 0, 0, and 1, 1. These are the parent function points, so don't connect them. Don't connect them. Just put them on your graph. Now we're gonna move them. Okay, they've been transformed. How am I going to move these guys? Inside is left and right. Left 2. Okay, I'll just write that to help myself out. And down 2. Nice. Okay, so let's take these 3 points, our parent function points, and we're gonna move them each to the left 2 and down 2. Okay, I'll start with this guy. Left 2, 1, 2, down 2, 1, 2. Boom. My next point, left 2, 1, 2, down 2, 1, 2. Boom. And my last point, left 2, 1, 2, and down 2, 1, 2. Still makes the same shape, right? We just moved all 3 of those points. Now you can connect them with your parabola because it's a quadratic. And boom, it's graphed. Okay, let's do that one more time. Number 12, what type of function is this function? Absolute value. We see those 2 bars, so you know the general shape and you know the parent function points. Okay, so let's go ahead and put the parent function points on our graph. Don't connect them though. -1, 1, 0, 0, 1, 1.
What do I see?
Okay. Now, this first transformation right here. What does this negative mean in front?
With the y-axis.
It's flipped over the y-axis. Oh, yeah. Oh well. Okay, so we gotta flip it, meaning it was going up. Our V shape was going up. Now it's gonna point down. Okay, so take these 2 points because 0, it's not gonna flip anything, right? Take the ones that would make it point up. Now they're pointing down. They're making this V shape that I'm not gonna connect yet go down. Okay, do not connect them yet because we still got to move these guys. Let's identify how we're going to move them. This -1 right here.
No, right.
Right 1. And
Up 2.
up 2. Nice. Beautiful. Okay, so now take these 3 points. We moved those top purple points so that they're pointing down. Okay, so now we're going to take these 3 points and move them each to the right 1 and up 2. Okay, so I'll start with this guy. Right 1, up 2. So he almost moved back to his own spot. Okay, this guy, right 1, up 2. Boom. And my last one, right 1, up 2. Now I can connect those 3 points. We flipped this guy over so he's pointing down. And we moved them to the right 1 and up 2.